Good evening, my dear students. We are going to learn second problem. Okay. The one dimension bar subjected to a axial load. So in this problem, the axial load is given as 10 kilonewton is acting at the free end. So taking it as two-dimension bar element is telling about which dimension. In the last problem we are talking about one dimension element, but this case is two-dimension bar element we need to assume here. Determine the first condition is nodal displacement we need to solve in this problem, as well as we need to solve the stresses in each element, as well as we need to solve the reaction at this support we need to solve. Let us see this figure. This is the cantilever beam figure. The cantilever beam is nothing but the one end of this beam is rigidly fixed and another end of the beam is totally free into the atmosphere. The total length of this beam is 1000 mm and the tensile load 10 kilonewton is acting at the free end, and the area of this two-dimension bar element is given as 10 power of 4 mm square, and the modulus of elasticity, or sometime we can say as Young's modulus, how much is given? 200 gigapascal is given. Then how to solve this problem? Let us see. First of all, write down the given data. First of all, we are taking this element, okay, for element number 1. So we are taking here, this is the first element, the center one we are taking as second node, sorry, this is the first node, second node, and this is third node. So you can observe here this figure, first node, center point, this is a center point, it is represented as second node, and this is a fixed end, it is represent the third node. The joining the third node to second node, it is a forming of element is first element. The joining of node from second node to the first node, the forming of element is 2. Okay dear, and let us see the displacement x is acting in the opposite direction of applied force. What I am telling, please listen. The x is applied in the opposite direction of applied force. So here this is the two-dimension figure. So that's what, here how many nodes are there? 1 2 3 3 nodes. Here how many number of nodal displacement? 3, because q1 q2 q3. q1 is acting at a point of 1, so that's what is represented as q1. Okay, q1. Okay, okay, let us see. So the q1 is nothing but the displacement is acting at a point of 1, q1 it is represent, and q2 is represent as the displacement, nodal displacement is acting at a point of 2, and q3 is the nodal displacement at point of 3. Okay dear, because what's going on? Okay, and f1 nothing but the nodal force. The nodal force is acting at a point of 1, we can say as f1. If the nodal force is acting at a point of 2, we can say as f2. If the nodal force is acting at a point of 3, we can say as f3. So here let us see a1 as it is, a2 also as it is it right? And because the Young's modulus, e1 as it is, e2 also as it is, l1 also as it is, and l2 also as it is. But in this case we are divided into how many nodes? 3 nodes. But in the last problem, in the one dimension element, we are divided into how many nodes? 2 nodes. But in this case we are divided into 3 nodes. How many elements? 2 elements. Okay dear. Then step number 3, we need to determination of elemental stiffness matrix we need to find out. So the what is the formula of elementary stiffness matrix? The elemental stiffness matrix formula is Ke is equal to AE by LE 1 minus of 1 minus 1 into 1. For if you want to consider the element 1, okay, same formula we have to use, just we have to change the value here. Instead of Ke we have to represent as K1, instead of AE we have to represent as A1, instead of capital E into small e we have to represent as E1 by, instead of LE we have to represent as L1, 1 minus of 1 minus 1 into 1. So A1 nothing but area of element, how much is given? 10 power of 4. And E1 Young's modulus or modulus of elasticity of a material, how much is given here? 200 gigapascal. Okay, so we know very well 1 Pascal is equal to 1 Newton per mm square. So here Newton per meter square. If you want to convert in giga, means it should be how much? 10 power of 9. Okay dear. So here should be 10 power of 3 2s are 6. This and this cancel, remaining should be how much? Here should be 3 only. So that's what I am representing directly here. 200 into 10 power of 3 Newton per mm square. Okay dear, let us see. Here A1 E1 by L1, A1 value how much? 10 power of 4. E1 value is how much? 200 into 10 power of 3 by L1 value is how much is there? 500. 1 minus of 1 minus 1 into 1. After that we need to divide this whole the value. If you divide, then you will get the answer is 4 into 10 power of 6, 1 minus of 1 minus 1 into 1. After that 10 power of 6 as it is, just you need to multiply this term. 4 into 1 4, 4 into minus 1 minus 4, 4 into minus 1 minus 4 and 4. Okay dear, so that's what it's considered as first node, second node, first node, second node. We can represent here first node, second node, first node, second node. Okay dear. If you want to consider for element 2, okay, so just we have to represent K2 is equal to A2 E2 by L2, 1 minus of 1 minus 1 into 1. So A2 as it is, how much is there? 10 power of 4 as it is. E2 how much is there? Same, 200 into 10 power of 3 by L2 value. So how much is there? 500. Just you need to divide this whole value, then you will get 4 into 10 power of 6. Just you need to multiply here direct. 4 minus 4 minus 4 into 4. Then we can take as here 1 2 2 3, because this is the first node, second node, this is the second node and third node, second node and third node. After that what we need to find out? Step 3, in which determination of global stiffness matrix we need to find out. K is equal to K1 plus K2. K1 value is how much is that here? 10 power of 6. Okay, and the value is K1, we are talking about which one? K1 value is how much? 4 minus 4 minus 4 4, 4 minus 4 minus 4 4. So here node how much is there? We have to present here above node 1 2 1 2. Okay, plus K2 value is how much? 10 power of 6, 4 minus 4 minus 4 4. Okay, the node is 2 3 2 3. After that let us see. If you want to write, because we want to combine K1 plus K2, then we have to take this common term here, 10 power of 6 and 10 power of 6 common here, 10 power of 6 only. Is it right? Here in this case we have to write in the global stiffness matrix. That's what we have to take. The here node is common, first node, second node and third node. First, second, third. We have to take in the systematic order, not in the arithmetic manner. We have to always, you need to remember, you have to represent this node in the systematic order only. 1 2 3 1 2 3. Then after that 1 into 1, 1 into 1 should be how much? 4. Got the point? 1 into 2, it should be how much? Minus 4. 1 into 3 is there here? Here 1 into 3 is not there. If it is not there, we have to consider here 0. Clear? Come to this point. 2 into 1, 2 into 1, how much value? Minus 4. 2 into 2, how much dear? 4. But here also there 2 into 2, again this 4 over. Again here 2, because into 2 into 3 here is there, not there, but this side is there. 2 into 3, how much value? Minus 4. 2 into 3 minus 4 over. After that, here 3 is there here? No. So you need to eliminate this point. Here is there. 3 into 1 is there? No. If it is not there means you have to consider as 0. Okay. Here 2 is there. 3 into 2. 3 into 2. How much you will get? Minus 4. 3 into 3. How much? 4. Okay dear. 10 power of 6 as it is. This 4 minus 4 0. 4 minus 4 0. Minus 4 as it is. 4 plus 4 it should be 8. Minus 4 0 minus 4 4. Okay dear. After that we need to find out the global force vector and displacement vector. The global force vector, here how many nodes are there? 3 nodes. So Q is represent the displacement vector. Okay. So here displacement vector Q equal to Q1, Q2, Q3, and the nodal force vector, it is represented as F1, F2, F3. So here F1, how much load is acting here at this point? Minus 10. Because why I am taking this minus 10, that is most important here. Let us see. So we are taking this point is 1 point. Okay dear. The opposite, this is the tensile force. Which nature is there? I told you tensile nature. Tensile nature we have to consider as a positive, but the displacement in which direction? Displacement is the opposite direction. If it is opposite direction, we need to consider as positive. We need to consider as negative. If it is move in a same direction, we have to consider as positive. This displacement x, if it is move in the same direction of wherever they applied the force, then we have to consider as positive, because in this case applied force is acting toward right side but displacement is acting toward left side. If it is the nature will be there, then you need to consider as minus in this case. Okay, so here I am taking here minus. How much force is there? 10 into 10 power of 3. F2 value, because at the force, how much force is acting at this point? How much force is acting at this node? We don't know. It is considered as 0. How much force is acting at this fixed end? Fixed end nothing but 0 force is acting. So that's what, this is 0 and this is also 0. 2 and 3 should be 0. The force 2 and 3 is 0. Any dot up to here? No dot. After that, in the step number 5, equilibrium equation for the continuum. Continuum nothing but body. Equilibrium equation for the body, we can say that. So K nothing but global stiffness matrix, Q nothing but displacement force vector, displacement vector, and F nothing but nodal force vector. So global stiffness matrix, it is represent as 10 power of 6 here. 10 power of 6, 4 minus 4 0 minus 4 8 minus 4 0 minus 4 4. We have to present Q1 value is Q1 Q2 Q3 Q1 Q2 Q3 equal to here F nothing but how much? Minus 10 0 0. So in this case, which one is the fixed end here? Node 3 is the fixed end. Node 3, if it is the fixed end, then K3 value should be how much? It should be 0. Then we need to eliminate the third row and third column. Third row and third column. The remaining should be, we have to represent in the equilibrium equation in this way. 10 power of 6 as it is. 4 minus 4 minus 4 8. 4 minus 4 minus 4 8. Remaining is Q1 Q2. Q1 Q2 equal to minus 10 into 10 power of 3 into 0. After that, 10 power of 6 as it is, just you need to multiply this term. 4 into Q1 4 Q1 minus 4 into Q2 minus 4 Q2 equal to minus 10 into 10 power of 3. Minus 4 into Q1 plus 8 into Q2 equal to 0. So it is considered as equation number 1 and it is considered as equation number 2. After getting the equation number 1, equation number 2, then we need to equate equation number 1 as well as equation number 2. After the getting the equation number 1, 4q1 4q2 equal to minus 10 into 10 power of 6. This 10 power of 6 we need to divide here. Okay dear, and here 4q1 as it is, 8q2 as it is, equal to 0 by 10 power of 6 should be how much? 0 by anything should be 0. 0 by anything should be 0. The value should be how much? 0. Then here this is negative and this positive, these terms will be cancelled, and here 8 minus of 4 should be how much? Remaining 4 q2 equal to, if you divide minus 10 into 10 power of 3 by 10 power of 6, you will get the answer is 0.01. Again you need to divide this 4 value here, then you will get the answer is q2 equal to how much? 0.0025 mm. After the getting the q2 value, again you need to substitute the q2 in equation number 2. Okay, here 4q1 plus 8q2 equal to 0. 4q1 how much dear? 4q1 as it is, if it is this positive, if it is moved toward right side, it will become as minus. This minus and this minus will cancel. The remaining should be 4q1 equal to 8q2. q1 is equal to 8q2 by 4. q1 equal to, so 4 ones are 4, 2s are remaining is minus 2 into 0.025. This is 0.025 value. It is the value of q2. If you multiply minus 2 into 0.025, then you will get the answer is minus 0.005 mm. After the getting the value of q1 q2, again then we need to find out the value of strain, as well as we need to find out the value of stress. That is important. After that, step number 7, determination of stress and strain we need to find. For the which element? For the element number 1. So here how many elements are there? Total 2 elements are there. For that reason the same step we need to follow. Is it right? Strain for the element number 1, strain equal to B into Q. That is a formula. So E1 equal to B into Q. So this B, it is represented by 1 by L1 minus 1 into 1, and Q is the displacement, Q1 Q2. 1 by L1 length is how much is there? 500 minus 1 into 1. Q1 value is how much is there? Minus 0.05. Q2 value is how much is there here? Minus 0.025. Then 1 by 500 as it is, just you need to multiply this term, minus into minus, it should be plus. 1 into 0.05, 0.05. Here plus into minus, minus. 1 into 0.025, 0.0025. Then if you subtract this whole the value, then you will get the answer is 5 into 10 power of 6. After the getting the 5 into 10 power of 6, again you need to find out this is the value of strain. That is the value of strain. After that we need to find out the value of stress. If you want to find out the value of stress, the same concept you need to follow, just E1 into B into Q. Okay, so E1 as it, E1 means modulus of elasticity into E1, this one is indicate strain. Okay, this E1 indicate modulus of elasticity, and this one is indicate that it's a strain of element number 1. E how much is given? 2 into 10 power of 3 is given. E1 how much is given? 5 into 10 power of 6. If you multiply this whole term, then you will get the answer is 1 Newton per mm square you will get. Again the same concept we have to follow here also for the element 2, strain in the element 2. So which formula we have to use? E2 is equal to B into Q. 1 by L2 minus 1 1. Here in the last case we are represented as Q1 Q2, but here Q2 Q3, Q2 Q3. Is it right? 1 by L2. L2 nothing but length should be remaining same. How much? 500 minus 1 into 1. And then Q2 how much? Q2 is 0.025. Q3 value is how much is there? The Q3 value is 0 because it is the fixed end. 1 by 500 minus 1, minus into minus should be plus. 1 into 0.025, 0.025 plus 1 into 0 should be 0. If you divide the whole the value, then you will get the answer is 5 into 10 power of 6. After the getting the value of strain, again you need to find out the value of stress in the element 2. Then same formula we have to follow here. Sigma 2 equal to E2 into BQ. E2 as it is, BQ we have to present as strain E2. So this modulus of elasticity of the material, how much value we got it here? We know very well, 200 into 10 power of 3, and strain value is 5 into 10 power of 6. If you multiply these terms, then you will get the value of stress in the element 2 is 1 Newton per mm square. In step number 8, we need to determination of reaction at the support we need to find out. So R is equal to the normal reaction equal to stiffness matrix into nodal displacement minus nodal force vector. So here how many nodes are there? Total 3 nodes. How many nodes? 3 nodes. The 3 node, how many reactions will be acting? 3 reactions will be acting. So we have to represent here the normal reaction R1. The normal reaction is acting at a point of 1. The normal reaction R2. The normal reaction R3 is acting at a point of 3. Is it right? Equal to this global stiffness matrix we have to represent as 10 power of 6, 4, minus 4, 0, minus 4, 8, minus 4, 0, minus 4 and 4. And the nodal displacement we can represent here minus 0.005, and here this is the value of Q2. This is a Q1, this is a Q2, minus 0.025, and Q3 value is, we know very well, it's a 0, minus the nodal force vector value. This is the F1 value is minus 10 into 10 power of 3, F2 value is 0, F3 value is 0, and then R1, R2, R3 equal to 10 power of 6. Just you need to multiply these terms. So first this row into this column, first row into this column, 4 into 0.005 plus minus 4, minus into minus, it should be plus 4 into 0.0025 plus 0 into 0, again minus 4, minus into minus, it should be plus, okay, 4 into 0.005 plus 8 plus into minus, here minus should be there, 8 into 0.025, okay, minus 4 into 0, okay, again you have to multiply this row into this column, 0 into minus 0.005 minus 4 into 0.0025 plus 4 into 0 minus 10 into 10 power of 3 0 comma 0. So if you add this value 4 into 0.005, then you will get the value is minus 0.02 plus 4 into 0.025, then you will get the value is 0.01. 0 into 0 should be 0. Again into multiply, minus into minus should be plus. 4 into 0.005, then you will get the answer is 0.02. 8 into minus, plus into minus, minus, is it right? 8 into 0.0025, then you will get the value is minus 0.02. Minus 4 into 0 should be 0. Okay dear? Again 0 into anything should be 0. Minus into minus, it should be plus. 4 into 0.025 should be value is 0.01. Plus 4 into anything should be 0, minus 10 into 10 power of 3 0 comma 0. If you add this whole the value, then you will get minus 0.02 plus 0.01, it should be minus 0.01. If you, because here positive and negative this terms will be cancelled, the value is should be 0. Again here only 0.01 equal to, sorry, minus 10 into 10 power of 3 0 comma 0. Again, so just now I told you, so first of all you have to take this value above only, R1 equal to this 10 power of 6 into 0.01 minus into minus plus 10 into 10 power of 3, then you will get the answer is 0 newtons. R2 equal to 10 power of 6 into 0 minus 0 equal to 0 newtons. R3 equal to 10 power of 6 into 0.0 minus 0 equal to 10 into 10 power of 3. So this means that the normal reaction at a point of 1 should be 0, the normal reaction at a point of 2 should be 0, the normal reaction R3 value is 10 into 10 power of 3. So the nodal displacement R Q1 equal to minus 0.005 mm, Q2 value is minus 0.0025 mm, and the Q3 should be 0. So if you want to find out the how much stresses is induced in the first element as well as in the second element. The stresses induced in the first element we got as the 1 Newton per mm square. The how much stresses is induced in the second element we have to represent as sigma 2 equal to 1 Newton per mm square. And the reaction at the support, if you want to find out, R1 value is 0, R2 value is 0, and R3, the normal reaction at the point of 3 is 10 into 10 power of 3. Okay dear, I hope so no one is having the doubt regarding this class. If you have the doubt, please write down the comment box, and you guys please subscribe my channel. Thank you.